right, recording. What day is it, Lauren?
15, if I'm not mistaken.
13. I think we missed that day. So this is like a wishful day 13. Should have
No.
been day 14.
That was 15.
What?
That was 15.
It's 15?
I think so.
Well, we'll fill that in later.
It's
We're
the
looking at
14th.
11.5 and 11.6 today. What we're gonna look at in this course, though, is 11.4, properties of logs. This section gives a lot of students grief. And it's really just memorizing shit. It really boils down to like making flashcards and memorizing the rules. I will show you how, since I don't know that I did it in the video that I posted, how you get some of them.
I think you have to move.
Am I not? Thank you. Let's zoom. Why doesn't zoom out work? What the fuck is going on here? Camera was turned. Camera was crooked. Okay. A little bright too. So properties of logs, we had log, I'll use base B of UV equals log of B of U, base B of U plus log base B of V. Same thing happens with division, but slightly different. Instead of adding, we subtract. And final rule, I hope you guys all watched the video on this, U to the N and N's in there. We can pull the N outside as a coefficient, as a multiplier. All right, let me show you how you get A. And B is very similar. For A, I'm gonna say M equals log base B of U. And N equals log base B of V. And this means that B to the M equals U. And this means that B to the N equals V. Those are the like switching between logs and exponents that we had before. So what we're going to start off looking at, those are some things that I'm going to use. We're going to look at what U times V is. U times V is B to the M times B to the N. Just based on how we defined them. What can I do with the B to the M and B to the N?
Add them together.
We can add the exponents together, that's correct. So I've got UV equals B to the M plus N. And what I'm going to do at this point is I'm going to take log base B of both sides. Let's just say log B of B to the M plus N. Now, we have talked about this before. This was in 11.1 or 2. This value is just M plus N. Because the log B and the B, these two cancel. So with them canceling, that means the left side says log base B of UV. And the right side just says M plus N. But we define M and N up here. M and N came from, we just set them up earlier. Pulling this information and plugging it in, we get log base B of UV equals log base B of U plus log base B of V. And that was our first property. A handy way to remember it, multiplication on the inside is addition on outside. Now, what would happen if I had, instead of U times V, the same setup here? Instead of U times V, I had U divided by V.
Turn into a fraction.
It would turn into some, well, yeah, we'd have, so like the different one doing this for B. We'd have U over B, which is BM over BN.
Yes,
And how do those combine?
you have to get the denominator to,
Well, we have the same base.
yes.
We have exponent rules, kind of like we had exponent rules for this. We have exponent rules for this. Do you remember what they are? It is subtraction. That turns into M minus N. And that's literally the only difference between these two proofs, if you want to give them a formal word for them. This would say M minus N, this would say M minus N, this would say M minus N, and we'd have a minus right here. Everything else looks the same. We can take a look at C real quick. C was, we're trying to show this one. So that's the one we're trying to show. What we're gonna start off, we're gonna say, let's go with M equals log base B of U. So that B to the M equals U. The same setup we had in the last one, we don't need the N in there, we're gonna leave that alone. So if I take this and I raise it to the nth power, I get B to the M to the N equals U to the N. When these are separated by parentheses, that becomes M times N. And that is a dot, not an I. We'll do what we did in the last problem, we'll take log base B of both sides. Here the M and the N come down because log B and base B cancel out. This is just M times N equals log base B of U to the N. And finally, we have M right here, that's this M right here. So I have N times M is log base B of U equals log base B of U to the N. That was the third rule we want to show. Which is interesting because this ties in like how arithmetics work. Multiplication is repeated addition. Subtraction is, I'm sorry, not subtraction, division is repeated subtraction.
Well, I always kind of wondered how those work in correlation, I guess. It makes sense now.
And finally, exponents are repeated multiplication. It's a shorthand way we do what we do. X times X times X, we say X cubed. We give it an exponent rather than doing the multiplying.
Wonder, is there any math symbols that you wish they had for like, you know, similar to like exponents that they don't have?
No. They have math symbols, or they have symbols for every type of math, more than you would want. Now you'll notice on the three rules we had, this is related to A, this is related to B, this is related to C. This was stuff on the inside. And this is stuff on the outside. And I'll bring those rules back up. Just so you can see them again. Maybe I'll do it like this. Multiplication on the inside, addition on the outside, division on the inside, subtraction on the outside, exponents on the inside, multiplication on the outside. It kind of takes arithmetic and uses it. It's kind of neat. I don't know if that's going to help you remember it, but it might. Everyone has their own little trick. I can, if you like that you struggle remembering shit, flashcards are your friend. I know that you use them for vocabulary and shit like that. Other classes, math has a vocabulary too, the formulas. They're worth remembering. I'll leave that up because just make sure everyone's caught up. And we'll go through some examples working these out. Everyone ready?
Yes,
Richard?
yeah.
So let's practice using this stuff. I'm gonna say condense. Which means turn into one log. Let's start with log base 2 of 3 plus log base 2 of x plus 4 minus log base 2 of y. So this will be my first example. I'm gonna take it slow, but you don't have to take it slow. You can do this all in one step. It is very, very important that if you want to combine any of them, they all have to have the same log base. These are the same.
It can't be log base like 3.
Log 3 and log 2 do not combine. So that's important. This is a requirement. Alright, so. What I'm gonna do is these two have a plus. I'm gonna do them first. Like I said, you can do these all at once, but I don't wanna like confuse anyone. Plus on the outside was multiplication on the inside. This turns into 3 times x plus 4 on the inside. And we still have minus log 2y. So plus turns into multiplication. And now subtraction turns into division. So I'm gonna have log base 2. I'll have 3 times x plus 4 on the top and y on the bottom.
Now we're done.
That's it.
Cool.
So with just a little bit of practice and remembering how the rules work, this is doable in one step.
Hey, maybe.
Time for the first actual practice example too. The rest was just showing how we came up with the formulas for 11.4. Let me give you guys one to try. Using this same, you can see what we had here. You try, we're gonna have log base 5 of 4 minus log base 5 a plus 1 plus log base 5 of b. Try to condense that into one. Okay, so. Any ideas what this should be?
We're gonna do division, right?
Just tell me what the answer is.
Oh, well, I hope I didn't get it wrong, but, I got 4 over, CA plus A,
So you had BA plus A down here,
A plus A, yes, and
which
log,
is
log,
B times A plus one.
and log, I put the log 5 with brackets, 2 brackets, and, yes,
Like that?
yes.
Anyone else get that? Or if not, did you get something different? What did you get? This isn't correct, so. It's close.
I got 4B over A plus 1.
Anyone get that? That one's the right answer. This minus only applies to this log. So that one is the only one that should be on bottom. So make sure that you keep the signs with what's going together. I'm guessing you transferred the minus sign to the B
Yeah.
on accident. Let's take a look at another one. I got room here, I can do it here. We're gonna have 3 log U plus 3 log B minus 2 log W. Now, we cannot start doing the addition and subtraction yet because we got things multiplied together. So remember, multipliers turn into exponents. So this becomes log U cubed plus log of B cubed minus log of W squared. And these are interchangeable lines. You can go either direction, they go back and forth. And then finally, we can put them together. We've got, this has an invisible plus sign, so it's on top. The V cubed has a plus sign, so it's on top. And they're multiplied together. And the W squared has a minus, so it's on bottom. Jackie's an overachiever. She was ready to take the test today.
I know I don't.
Since you don't have a base listed, are we just assuming that it's like a base of 10?
Yep,
Okay.
that's in fact. Log with no base. Means log base 10. Alright, let me give you guys a minute. I guess I need some parentheses here. So first thing you want to do is move the multipliers up as exponents. Is ready? Anyone got an answer? Go for it.
I'll add, and then in parentheses, x2 times z5 over y over times w6.
Anyone else get that? I assume that's what you meant.
Oh, it's supposed to be brackets.
Parentheses is fine.
I think it's Y4 instead of Y5.
He said Y4, didn't he?
Oh, you did.
So we generally, other than the way you said it, is fine. This is correct. We generally say squared for two. Cubed for three, and then any other number we'll say. To the fifth power or to the fourth power. Saying Z5 looks like that.
Yeah.
That's not it. So I knew you meant that, but that's right. All right, I'm gonna go through another one that's kind of go through it quick because I wanna do the other way. Where we expand rather than condense. But let's have one that just looks absolutely terrible. First off, I'm gonna distribute. That -1/2. If I distribute the -1/2 of this, I have -1/2. Ln of x plus 1. And when I distribute -1/2 here, I have +1/2 ln of x minus 1, y. I think I said x plus 1, but I meant x plus y. Then we'll push them together or do the exponents. This is ln of w minus 5 squared. Minus ln. I guess I'll do brackets and parentheses. I'm just leaving the minus on the outside, although I could technically move it inside. We move the 1/2 inside here. And move the 3 in there. Now, anything with a negative goes on bottom. And anything that doesn't goes on top. And I probably wouldn't leave it like that. Fractional exponents are radicals. I would probably write it as this.
Different than your actual check, like, it says, champion. Yeah, it's. It doesn't feel like you're getting one, I don't care. Okay.
You guys ready for more?
Yes.
Now we're gonna take a look at expanding. So I've got log base 5 of x squared y. The first thing we can do is recognize that x squared and y are separate. And multiplication on the inside turns to addition on the outside. And then finally, exponents can be brought down as multipliers. This connection is easier to see with actual numbers like we have here and doing it expansion. Like I could alternatively, if this helps you guys, I could write log 5x squared as log 5 x times x. And multiplication turns into addition. And since I have two of them and they're the same, I could add those together. So there's another way to do the exponents on expanding. If you treat it like multiplication. Whether you remember that or not, I think it's easy to just remember to bring the exponent down. Practice and maybe flashcards for memorization is really the way to tackle this one. Let me give you guys a quick one to try. Oh shit, Davis got attacked by a fucking lawnmower and lost.
Yeah, that's true. It was time. It was time.
Anyone have an answer?
Yes, going off to example 2 log base 2 z plus log base 2. Well,
Anyone else get that? Maybe in the other order? That's right, this is good, excellent. So separate them and then bring the power down. I only got a couple minutes left, so I'm gonna kind of go through the next couple a little bit faster. If we take a look at natural log of e squared x. This is natural log of e squared plus natural log of x. And we can bring the exponent down. But that is, what's ln? What's the base on ln? No. If I just have a log, it'd be base 10. ln is base e. So does anyone know what this value equals? You can figure out without a calculator real quick. Log base e of e equals y is the same thing as saying e to the y equals e. So y has to equal 1, right?
Yes.
So that just ends up being 2 times 1 is 2 plus natural log of x. So worth remembering, natural log of e, log of 10 with no base, these two equal 1. That's worth flashcarding, because you'd be surprised how often students forget this shit. And they're in like Calc 3 and stuff. Yeah.
Well, if E was changed out for any other number, it was both log to that number, like log 15, would it still be 1?
Any base with anything, the exact same thing on the inside is 1. Log base b of b equals 1. Ooh. Now, they might give you a tricky one. I'm gonna slip one more in. Let's say we've got log base 2 of 4x squared minus 12x plus 8. I think this is a good idea to factor first. I can take out the 4. And then I can factor this. This is x minus 2 and x minus 1. So I've got log base 2 of 4 plus log base 2 of x minus 2 plus log base 2 of x minus 1. But that's actually not done. If you throw this in the calculator, you get a value, but this is log base 2 of 2 squared. That one is. And so I could pull the exponent out. And this brings up Davis's question you just asked, same base, same inside. That's 2 times 1. So that first thing is just 2. And the other ones are untouched. Because they have an X in them. And with that, I'll stop that lecture video.